These next few sections will be all about simplifying radicals. So first, in section 9.4a, we'll simplify them by combining like terms if we can, okay? So first, we've got the square root of 50 plus the square root of 98. It doesn't look like you can combine these because they don't have the same quantity underneath the radical symbol. But let's see what happens when we simplify each of these terms separately, and then we'll see that we're able to actually combine them. So let's look at the number 50. 50 can be factored as 25 times 2, right? So the square root of 25 is 5. That's on the outside. And then the 2 gets left on the inside. So the square root of 50 is the same as 5 root 2. Now how about 98? 98 is 2 times 49. So square root of 49 is 7, which I can write on the outside. And then I have a square root of 2 left. The 2 is left underneath the radical symbol. So now notice this is 5 root 2 plus 7 root 2. You can add these to get together the same way you could with, say, like 5x plus 7x. They're like terms. There's 5 x's plus 7 more x's. You can add them together by doing 5 plus 7 as the coefficient, 5 plus 7 groups of x. So this will be 12x. So again, you can add the like terms together by just adding the coefficients together. So you can think of that here as the same way. The square root of 2, even though it's a number, you can think of the square root of 2 as like that's sort of like the variable x in this case. See, the coefficient out front is 5, and here your coefficient out front is 7. So adding these together, 5 plus 7 is 12 root 2. So again, I want you to think of this square root of 2. This is sort of like your x. So it's like 5x plus 7x. So you can combine them together as long as the amount underneath the root symbol is exactly the same, and as long as they're the same index root, you can just go ahead and add the coefficients together. Okay, great. Let's move on to the next example. Square root of 20 divided by the square root of 180. So if I were to simplify this, what I would think about doing is first see if you can simplify 20 over 180. Think of this as the square root of 20 over 180. Well, you can sort of divide both the numerator and denominator by 10. You do that by like crossing out a 0, right? So you know that 10 goes into 20, 10 also goes into 180. So this will be the square root of 2 over 18, right? You can actually simplify it further by noticing that these are both even numbers, so 2 should divide into both the numerator and denominator. So this is the square root of 1/9. Great. Now you can simplify this further by taking, square root of 1 over square root of 9, which is 1 over square root of 9 is 3. So square root of 20 over square root of 180 simplifies to just 1/3. All right, let's do this next example. Again, these two don't look like terms, but I think what I'd like to do is see if I can simplify them a little bit. And if I can, then I'll try and combine them together. So let's think of these things separately as like square root of x squared times the square root of y to the 4th times the square root of z. And this will be square root of x to the 4th times the square root of z cubed. Okay, so I'm going to simplify this. Square root of x squared is just x. The square root of y to the 4th is y squared. And then I just have 1z left underneath the root symbol. Plus square root of x to the 4th is x squared. And the square root of z cubed, well, 1z comes out, 1z is left underneath. Okay, now, this quantity is simplified as far as it'll go, and so is this one. Notice they're not actually like terms, even though they have the same radical part. They don't have the same variables raised to the same power on the outside here. So I simplified each term, but I cannot combine it any further.